Washington State University. Go Cougs!
Hello and welcome back to the course on collecting smartphone sensor data using iOS. We're in Module 3 where we're learning how to communicate the sensor data to a web server. And in Part 2 of this module, we'll look at how to package up the data into JSON format in preparation to send it over the web. Specifically, we'll be doing three things. First, we'll be adding to our sensor app so that we can always get access to the current sensor data readings. We'll also learn how to extract the current time according to the device, and then do the conversion to a JSON string. So first of all, to be able to access the current motion data, what we're going to do is we're just going to create a new variable of type core motion device motion, which is the data structure that's used to deliver the motion data. And that data is, of course, delivered to the motion handler that we've already written. But we're going to add one more line here so that when we are sure that we have a new valid piece of motion data, we will set it to our current motion variable. So that's basically using a global variable that we can access anywhere in our app and be assured that it has the most recent motion sensor data readings in it. Likewise, for the location data, we'll do something similar. We'll create a global variable called current location, which is of type core location. And again, that will be set inside the main function that's called whenever a new location data is available. So in this location manager function, we will set this new location value to our current location. So again, we have access to it. Note that I made both of these variables an optional using the question mark. And that means that there is a possibility that the data is not available. So when we go to create our JSON string representation of this data, we want to do something appropriate in the case that a particular piece of data is not available. We don't want to send something that's essentially wrong to our server. Okay, so let's go ahead and make those changes to our app, and then we'll take a look at the next step. So I will go back into our sensor app, go into the viewcontroller.swift file, then up at the top is where I'm going to add those two global variables. So the first one, we will call it current motion, and it's of type core motion device motion, and I'll make it an optional. And second, we have our current location, which is of type CL location, and we'll make that an optional as well. Then for the current motion, we'll set that down here in our motion handler. So right when we're sure we have some device motion data, that's where we'll set the current motion value to that. And then likewise down in the location manager, as soon as we have extracted the next location, we will set our current location variable to that value. So that's all we need to be able to access the current location. So obviously down here in the, because it's up here, when we click on the send data, we will want to access we want to access those two variables and extract their sensor data and again put it in JSON format. Okay, so before we do that specifically, there's one more piece of information we need, and that is the current time. We need to know the timestamp for the sensor data. So let's go back into the notes. Now, the first thing we need to decide is what time do we actually want to report. There's several views on time available to us. One is the local time of the device itself. One is the universal time, or Greenwich Mean Time, which is something that is the same around the world. And then, of course, there's the time on the server. The server could be anywhere in the world, and so the time on the server could be different than the time for the device itself. Now, when you're dealing with sensor data and you're analyzing it, a lot of the behavior and the patterns you may learn are based on the time of day. And so for that reason, we really want to store the local time of the device. So that's the time that the time zone the user is in, and their current time at which these sensor values were recorded. But we still might want to know what time zone they're in so that we can coordinate their local times with other local times around the world. So to do that, we are going to use a class available in iOS called a date formatter. And specifically, the date formatter will allow us to extract the local time and the time zone, or the UTC offset, which will tell us what time zone the device is in. So specifically, if we look at this function here, this function is what we'll be using to get a string that represents the current time. And if I can jump ahead just one slide here, this is what the string will ultimately look like. This is our timestamp. So it has the date, the time of day. We're going to get down to millisecond precision on our time. And then we have the UTC offset, which tells us what time zone this is in. But this is local time, and again, that's what we generally want. So to do that, we create an instance of this date formatter class. We tell it what the format is of the date that we want to generate a string for. And this is kind of a cryptic bunch of symbols that tell us what that format looks like. So the date formatter has this date format string, and this basically means we want a 4-digit year, a 2-digit month. So even if the month is, say February, it would be a 02 instead of just 2. And likewise, we want a 2-digit day separated by dashes. Then same for the time, we want a 2-digit hour, and this is going to be military time, so it's 0 to 23. A 2-digit minute from 00 up to 59, and a 2-digit second from 00 to 59. And then after the integer seconds, we're going to have, again, millisecond precision. So we use this capital S to specify how many digits of precision we want for our timestamp. And then lastly, these 3 capital Z's represent the UTC offset, which tells us what time zone we're in. So we use this string to specify the date format, and then we just want to get the current date and time as our timestamp. So to get the current date and time, we use an instance of the date class. We'll call that now. And then this date formatter has the ability to produce a string according to its current format from a date that you pass in. So this is how we'll get the actual string. and then we're going to return that, and that'll be used inside of our function that converts everything to JSON. So let's add this function to our code. I'll get out of the presentation and copy that code, and then we'll go back into Xcode, and I'll start a new section here called communication, and our first piece there will be this function that converts the local time to a string. Now you might at this point want to try this out, and that's a perfectly reasonable thing to do, but this is actually a good time to revisit our playground. You might remember we use the playground to try things out in iOS so that we don't have to make small changes, rerun the simulator, and print something out to the console. So in this case, the playground is a good way to do that. So let me copy this part of the code, go back into our playground. If you have some entries left over here, you can just hit Control-A and delete to get rid of those. First thing I'm going to do is import the UI kit, because that's where the date formatter resides. And then I'll copy in that code, and it should run after a while. So here you see that this final string is in fact what we want, and that's how we're going to get our value. Now if you wanted to play around with it, maybe I don't want millisecond precision, I can see what effect that has. So this is a good place to play around to get the date format exactly the way you want, and then of course you can copy that back into the code. Okay, so that's how we will get our timestamp for our sensor data. And then the last piece is to convert everything to the JSON format. So let's go back into our notes. So you already saw that this is an example of what we want the JSON format to look like. So again, we're using what's called an object in JSON, which is a comma-separated list of name-value pairs. The names here, we have timestamp, and then we have our sensor values. Oop, must misspell that one. And then, of course, the values themselves. Now, JSON would allow me for these floating point numbers to just enter them just as they are. But I generally like to make everything a string, because there's always issues of precision and how floating point and integers are actually represented in the computer in which, say our device, and then they're transferred to another computer, which could be a completely different architecture, and it would try to interpret what those values are. So generally I find it's best just to put everything in a string, and then let the scripts on either end pick apart those strings and convert them back into appropriate values. So that's why everything is a string here. Okay, so here's the actual code for converting all of our sensor data into a JSON string. So let me walk through this, and then we'll add it to our code. It's not really as complicated as it looks. First thing, we'll use our timestamp to string function to get the timestamp. So that's a string representing the time. And we'll start out our JSON string with this first name value pair for our timestamp, again followed by a comma. Next, we'll add in the motion sensor data, if it is in fact available. Remember, we're using this optional chaining here. If the current motion is available, then we store it in this CURR motion variable. And then we add to our JSON all of the name value pairs for the acceleration and rotation, and then the actual values of those sensor readings. This slash quotation mark here is how we specify a string that contains a quotation mark. So that's why we're using this slash quotation. Now in this case, if for some reason the current motion data isn't available, we're just going to put NA for not available for all of those values. And then likewise for the current location, if it's available, then we'll add 3 more entries to our JSON object for latitude, longitude, and altitude, again accessing it the same way we did when we printed it to the view of our app. And again, if the current location data isn't available for some reason, we'll put NA for not available for those values. Lastly, we'll finish it off with the final curly brace and return that string as our JSON format of our sensor data. Okay, so let's add that to our app. Back into Xcode, we'll add it right here. And fix up our formatting a little bit. This should all be one line here. Okay, so there's our sensor data to JSON string. And let's go ahead and test this out. So back up here when we call the sensor data tapped, which calls sensor data, I'm going to go ahead and grab that data string, call it sensor data string, and let's see, what did we call that? So sensor data to JSON is what we want. Sensor data, data to JSON. So I'm just going to print that out. And we'll see that appear down here in the console. Okay, so let's go ahead and try that out. Start up the simulator. So I'm going to move it over here a little bit so that I can see the console down here. I see that the console isn't actually in the view, so before I run this, if you go up to View and under Debug area, say Activate Console, you'll see that we have our little console down here. So that's where when we do a print statement, that's where the information will display. So back to our app, let me start that up. And if you recall, the motion data, the simulator doesn't have a way to simulate motion data, but it is simulating the location data. So let me click on Send. And you can see here we printed out the JSON format for our sensor data. So we have our timestamp. The motion data is all not available, again, just because we're in the simulator, but we do see values for the location. So this is the JSON data that we ultimately want to send to our web server. Okay, so back in the notes, just to finish that off. So we now have our sensor data being collected, and whenever we want, we can produce a JSON formatted string of that sensor data. So obviously the last piece is to actually send the data to the web server and have it stored there. So we'll do that in part 3.